This is the driver's time. And then we will also check the worker's time. If in case of both one worker is engaged and two workers are engaged, we will check for both the driver as well as the workers. So we will check one case of if only one worker is engaged. So if only one worker is engaged, then what is the total cost to the organization? So average time spent by the both worker as well as the driver has to be taken into consideration. Now we will calculate if only one worker is available, because here what happens if only one worker is there, what happens if the driver has to wait? When there are two workers working in the system, probably the trucks will be divided among the workers, and that will be the time of waiting time of the driver will reduce significantly, so the cost also will come down. Here lambda is given 5, that means lambda squared by mu into mu minus lambda, that means 8 into 8 minus 5. So that is given by 25 by 24. Right? 25 by 24 will give us, and hourly rate of one worker is 400. Per shift it is 400. That means per hour 50 rupees, because that shift has 8 hours. Or we can say hourly cost of waiting of truck drivers is given by 25 by 24 into 500 by 8, which will give us 65 rupees 10 paise. So these many truck drivers are in the queue. Only if one driver is only one worker is engaged and these many drivers are waiting in the queue, so that is the cost. So here the total cost, total hourly cost is equal to 50 plus 65.10. That will give us 115.10. And we will check a case of when two workers are engaged. So when we find out if two workers are engaged, what is the cost, and we will see if whichever is resulting in lesser cost, that we have to find out. So if two workers are engaged, then what is the time that the drivers are waiting in the queue? How many drivers are waiting in the queue per hour? So it is given by lambda is 5, whereas mu becomes 2 into 8, 16. Because when one worker was there, he was able to unload 8 trucks, and here two workers means 16 trucks they can unload together. So now we will find out average number of truck drivers waiting in the queue. So we will see what is the value. That is again given by lambda square divided by mu into mu minus lambda. So we will substitute those values, that is 5 square 25, 5 into 5 25 divided by 16 into 16 minus 5, that is given by 25 by 16 into 11, which will give us 176. Now we will find the value of the 25 by the hourly cost. So what we will do is we will find out the cost of truck drivers as well as we will take the hourly cost of these workers also, so that when we sum up both of them we will get the total value. Here it is 8.87 and the workers cost is 100 rupees. So total hourly cost becomes 100 plus 8 rupees 87 paise, that means 108.87. Earlier it was 115 something. So here the waiting time is also reduced as well as cost is also reduced. So cost of 2 workers per hour is given by 2 into 50. The same thing 100 we have taken there. So that is 100. So this 100 plus 8.87 will give us 108.87. This is how we are learning. And when we looked at that, we find that cost as well as convenience also. It results in lesser waiting time for drivers also, which will result in goodwill at the organization. Then we can write the conclusion as the cost will be lower if we engage 2 workers. That is a desirable thing, or it is suggested. So if 2 workers are engaged. Now we will go for another problem in queuing. So it's a problem which we face at bank counter. So there are several issues given in this. How many customers are coming and how many customers are being serviced in an hour. At the same time, how much time it is taking to be in the system, how many customers are in the queue, which we also call that as the length of the queue. So the problem is given like this. At a bank counter, on an average, a customer arrives every 5 minutes. What actually, when they have given the arrival or service rate in minutes, it is necessary that we have to convert them into hourly rate. In all the queuing problems, it is a procedure that will convert them into hourly rate, and arrival rate is always given by lambda, which is per hour. So similarly, service rate is also given by hourly rate, which is expressed by mu. So if it is given in minutes, we have to convert that into our hourly rate. 5 minutes every customer is arriving means per hour how many customers, that will be the lambda. Similarly, if every 3 minutes one customer is serviced means how many customers per hour, that means 20 customers per hour, which is given by mu. And what are the things that are being asked here is average waiting time in the queue for the customers. And if a customer enters into the queue, how much time he has to wait on an average. It is not for every customer. Some customers may have more time to wait, some customers may not be waiting much time. Similarly, second question what is asked here is average number of customers waiting in the queue or length of the queue. Both means same. So how many people are waiting in the queue, or which we also call that as length of the queue. Similarly, probability that the counter is idle. So what is the time or what is the probability that the counter is idle? What that means is there are no customers in the queue. So the counter is completely empty. What is the probability? That means for what part of time that will be idle, or what is the probability that the counter may be idle. Average waiting time in the system. Actually, average waiting time in the system here means the waiting time in the queue plus service time. That is known as average time in the system, which we call that as WS. So, and similarly, utilization factor in the of the counter. That means to what extent the counter has been used. That is known as utilization factor. So then actually, if utilization factor is subtracted from 1, we will get the idle time.